going to the next part that we're going to discuss, that is using match statements to match patterns in dictionaries. Now, again, it is exactly similar to the first file, the simple match statement that we discussed right at the start. But again, the reason I'm going through lists previously and dictionaries now is that you can understand the usage. You can see the code right in front of you to understand exactly how this works, right? You might, if you're new to Python, or for anyone who's learned Python, really, at the start you realize you learn syntax for a certain application within Python, let's say, right? But when you actually start coding, you realize in certain cases you don't know exactly how to use that, so you look it up just to get a reference point on how it's going to work out. So in this case, I'm giving you those reference points, so it becomes clear to you exactly how you use it, how you use match statements in different contexts, or with different data structures. In this case, lists, then dictionaries. So in dictionaries, if you look at line 1, we set up a simple function that matches dictionaries with which is called match dict, and it takes an input called data. In line 2, we use the match keyword and telling Python that we're going to match the cases with the data input we're going to get in, right? And in case 1 on line 3, we match for a dictionary which has a key name with the value Alice and a key age with not a specific value restriction. So what's happening here is we're going to make sure the name of that dictionary is Alice, right? And it has age, but we do not specify exactly what age it could be. It could be any age for what Python cares. But as long as it has the name Alice and it has age defined within that, we're going to use the case number 1 on line 3 and print the name Alice along with the age, whatever that may be. In case 2, the reason I was specifying that we're going to detect for the presence of the key age within the previous dictionary, other than the name being Alice, is because on case 2, you can understand we're just looking for the name Bob. So here it does not matter whether it has an age or not. As long as the name is Bob, it's going to default to it and print name is Bob. And case number 3 is again our default case. That is very important. And if the first two cases don't match, we print no match. Now on lines 11, 12, and 13, you'll notice we are going to test for this user. So first is the name Alice and age 30. We send it out there, and we get the output on the comment right next to this example usage is name Alice age 30. As we sent it out, as we ran that function, this is going to be the output. On output or example usage number 2, we're going to send in the dictionary name with Bob. So the output is going to be name is Bob, as we defined above in case 2. And in example usage number 3, we're going to test name is Charlie. So the output is no match. As we can see, case 1 and case 2 do not correspond with this dictionary. They do not match the dictionary values. So it defaults to case 3, which is no match. So with that, we need to move on to the next and rather probably the most difficult portion of our entire video today. So we worked with understanding simple pattern matching with match statements. Then we use list matching. Then we use dictionary matching. Now all of that is very simple. But what is I think probably the most difficult portion for you to digest is, let's say you create a customized data structure within Python using class, right? Using a class statement, like you can see in this file here. And with a customized data structure, you can't exactly pinpoint how we're going to use that in a match case statement. Like most people, some people might even be able to, understand that, but some people might not be. So we're just going to go over that to understand exactly how you can leverage match case statements within a customized variable. Because if you can do that, then you can work with this match case statements in whatever situation you find yourself in. And this is a very, very versatile and powerful tool to have in your arsenal especially if you're a professional programmer or intending to become a professional programmer. So in line 1 to 4, we define a class or a customized variable called point, where we define values x and y. To give you a clear context, these are coordinates on a graph. So these are x and y coordinates that we're defining as a data structure called point here. And we're defining that this variable has two values, x and y, just like our coordinates on a graph, x and y values. Now we define from line 6 onwards a new function called match point. In match point, we take an endpoint called point, which is a reference to the new data structure that we established above. So in line 7, you'll use, along with the match keyword, we use the input that we're getting in the function called point. So we need to compare whatever input point value we get in this function with the cases below the match keyword. Case 1 tests for 0.00. So it tests for the origin of the graph. So if the points that are fed into this function with x and y being 0, then it's going to print origin, as you can see on line 8. In line 10, we have case number 2, which tests for x always being 0 and y being whatever. Y could be whatever, but x always needs to be 0 for case 2 to run true. So if case 2 is true, that means x is 0, and we are on the y-axis at a certain value of y. And we print that exactly in this case, as you can see below, on the y-axis at y equals to whatever value of y we are on. On case 3 on line 12. Now this is a little bit unique. Here we don't test for any specific point. As you can see, point needs to be x comma y. It could be whatever value of x and whatever value of y. But if you look clearly at further down this case, we have if x equals y here. Now, this shows you that conditionals could be further added within case statements to test out or test for certain things within the case statement. So this is done for more complex matching cases. So this is a good thing to have in mind when you're using match case statements, that you can further pre-qualify conditions within a match case statement using if statements within that. So if x and y are equal for whatever value of an x and y, then we print on the diagonal at whatever values of x and y. Now case 4 is the default case at line 14. And this simply prints no match. If the value inputted in the function does not match case 1, 2, and 3, it prints no match. Now on line 18 onwards, 17 onwards rather, you'll see our example usage. So we define the point, which is the new data structure that we defined at the top of this document, 0, 0. Then we test that new variable called origin within our function, and the output we get is origin, because 0, 0 is the origin on a graph. On line 21, we define a variable called on y-axis with x being 0 and y being 5. Then we test for this variable using the function. The output is on the y-axis at y equals to 5, and the reason being case 2 tests for any value where x is 0 and y could be whatever, and prints out on the y-axis at a certain value. So that tests out to be functioning. On line 24, we define a variable called diagonal with points 3 and 3. Here x and y are equal. When we test that within our function, we get the output on the diagonal. As you can see on case 3, that's exactly what the output should be. So, and on case 4, where we test for two random x and y values within the point data structure, and when we test that within the function, we get the output no match, because it doesn't match case 1, 2, and 3, and it defaults to case 4, which is no match. Structural pattern matching. At the end, I would like to say that structural pattern matching in Python adds a powerful and expressive tool to handle different cases and patterns in your code, making it readable, concise, and very, very flexible in its usage for you to when you're developing codes or when you do pattern matching for whatever reason that it may be. Also, I would like to pre-qualify that match case statements are only available in Python version 3.1. So if you use Python below that, match case statements won't work because Python does not have this feature prior to Python 3.1. That is all in pattern matching within Python. If you have any queries, if you have any questions, please do let us know in the comments below. Give us a like. And before we wrap this video up, George, would you like anything at the end?
Nope, I think you said everything. Thanks, guys.
See you on our next video.